Hello everyone, I'm Paul and today we're solving problem 3321. Find x sum of all k-long subarrays Q. This is a hard one and here I will show you how to solve this efficiently. If you haven't seen part 1 yet, I recommend you to go and watch that video first. It's in my channel. This is basically the same as part 1. We are solving subproblems of size 6. So for example here we have a subproblem and we need to find the two most frequent elements in this subarray, and the result in this case is 6. Why? Well, because the two most frequent elements are 1 and 2, and if we do 1 plus 1 plus 2 plus 2, the result is 6. Now, we have another subproblem here, and if we do the same, the result is 10. And we have another subproblem here. If we do the same, the result is 12. So for this input, the result is an array with 6, 10, and 12. Okay? Now remember what we did for part 1. For every subproblem, we build a frequency map, and from the frequency map, we build an array, and then we sort the array 2 times, and that's how we can get the x most frequent elements and get the corresponding value to store in the result. We repeat the same process for every subproblem, and finally we return this. And this is fine, but the problem here is in the constraints, and this is the only difference with part 1. Here, these variables x, k, and n are smaller or equal to 10 to the power of 5. And this means we need to think in something smaller than big O of n squared time complexity. Okay, so we need to think about something else. And the trick here is the following. Instead of solving each problem from scratch, we are keeping track of previous information to reduce time complexity. Let's see what I mean. We will have two sorted lists. And in case you know how this works, here we can store numbers, arrays, or tuples. In this case, we are storing tuples. And this automatically sorts elements in big O of log n time complexity. So this is exactly what we want given the constraints. Now, the way this works is the following. First, we sort tuples. Let's say we have 2 tuples. We sort tuples first by index 0, then by index 1. And this is exactly what we want. Why? Well, because we are trying to find the x most frequent elements every time. So if we can sort frequencies, this is much easier. So we can put frequencies at index 0 and keys at index 1. And this is very important because remember, the problem description says that if we have a tie, we need to keep the highest key. Okay, so we sort this automatically in ascending order by index 0 and by index 1. And we have 2 sort lists, one for the x most frequent elements, we will call this top, and the other one for the rest of the elements, we will call this low. So first we are here at index 0. And we have a 1, so we go to our frequency map and we add number 1 with a frequency of 1. And now we are adding this information to low. And remember the format. First we have the frequency, then the key. And now we can rebalance this. And what this means is if top is not full or we have elements to swap with low, we need to move this here. In this case, x is 2, so we have 2 empty spaces here. So we can move this here. So we remove this tuple from low and add the same to top. And by doing this, we are following a standard logic, which is we start from one element. We add the corresponding element to the frequency map. Then we add the corresponding element to low, and then from low we update top if necessary. And of course we remove the corresponding information from low if necessary. So here you can see how we follow this line. And the current result for this subproblem is 1 times 1, frequency times value. So we add to current 1. So now we are here, and maybe you are thinking about doing the same as before. We go to the frequency map at 1, add 1 here, we add this information to low, so we add a tuple with 2 and 1, and here we have a problem. Why? Well, because we have repeated numbers. We have 1 here and 1 here, and we want to avoid this. So the first step would be to remove this. So let's step back for a moment. Let's say we are here again. The first step is to check if we have a 1 in the frequency map. We have it right here, so we know that somewhere here we have a tuple with a frequency of 1 and the number 1, and that tuple is here. So we can remove this, and we subtract 1 times 1 from current. This is now 0. Now we are ready to add this to the frequency map. So we go here, we add 1, and now we add this information to low. So we have a tuple with 2, 1. And now we are checking if we need to balance this. Here x is 2, we have 0 elements in top, so we can move this to top. We remove this from low, and we need to add 2 times 1 to current, so this is now 2. And what this means is the result of this subproblem is 2. But here we only have 2 elements and k is 6, so this is not enough, meaning we keep the result as it is and continue. Now we are here, we are checking if we have 2 in the frequency map, and we don't, so we add 2 with a count of 1. And now we need to add this information in low, so we add a tuple with a frequency of 1 and the number 2. And now we are checking if we need to balance this. Here we only have 1 element, but x is 2, so we can move this tuple here. We remove the tuple from low, and we add 2 times 1 to current. This is 4. Now we are here, so we go to the frequency map. We check if we have a 2, and we do. So we are looking for a tuple with a frequency of 1 and the number 2. And we have this tuple right here. So we remove this and remove 2 times 1 from current. This is 2. And now we are ready to add this. So we go to the frequency map at 2. We add 1 here. This is 2. And we add a tuple with this information in low, 2, 2. And now we're checking if we need to balance this. Here we only have 1 element, but x is 2, so we can add another element, meaning we add a tuple with 2, 2. Remove this from here and add 2 times 2 from current, so this is now 6, meaning the result of this subproblem is 6. But here we only have 4 elements. At k is 6, so we can't add anything to the result and continue. Now we are here, so we go to the frequency map. We add 3. The count for this is 1. This is the first 3 that we see. So we go to low and add this information, meaning a tuple with 1, 3. And now we are checking if we need to balance this. And we don't. Why? Well, here we have 2 elements and x is 2, so we can't add this here. But maybe we can swap elements. Maybe we can swap these 2 or these 2. And the answer is we don't. Why? Well, because the frequency of this is 1 and the frequency of this is 2. And we are trying to get elements with the maximum frequency. So we want to keep this tuple instead of this. So we keep this as it is and continue. Now we are here, so we go to the frequency map and we check if we have number 4, and we don't, so we add 4 with a count of 1. And we need to add this information in low, so we add a tuple with frequency and number, and we are checking if we need to balance this. So here we have 2 elements and x is 2, so we can't add anything, but maybe we can swap elements. But the answer is we can't. Why? Well, because the last element here has a frequency of 1 and the first element here has a frequency of 2. So we keep this as it is, and now the result of this subproblem is 6. And here we have 6 elements, which is equal to k, which is what we want. So at this point we can add current to the result and continue. Now we are here and we do the same. We go to the frequency map and we are checking if we have number 2. We have it right here. So somewhere we have a tuple with 2 and 2. And this tuple is here. So we remove this and we subtract 2 times 2 from current. So this is 2 again. And now we are ready to add this. So we go to the frequency map again, add 2 and add 1 here. Sorry, this is 3. And we need to add this information in low. So we add a tuple with 3, 2. And now we are checking if we need to balance this. And here we only have one element, but x is 2. So we can move this element to top. And we add 3 times 2 to current. So 2 plus 6 is 8. So the result for this subproblem is 8. Now the problem is that here we have 7 elements, but k is 6. So we should remove this element, and from now on we always want a window of 6 elements. Remember, this is a sliding window problem. Once we reach 6 elements, we want to maintain 6 elements. And the question is, how can we remove this? Well, we can do exactly the same, but instead of adding 1, we can add a -1. So let's see the full process. First, we are checking if we have this in the frequency map. We have it right here. So somewhere we have a tuple with 2, 1. That tuple is here, so we can remove this and subtract 2 times 1 from here. This is 6 again. Now we are ready to add a -1. So we go to the frequency map again, we go here and subtract 1. This is 1 now. And we need to add this information in low, so we add a tuple with 1, 1. And now we are checking if we need to balance this. Now remember, we are working with sorted lists, so this would be the correct order here. First, we sort everything by index 0, then by index 1. So here we only have one element, but x is 2. So we can take one of these elements and move it here. And the question is which one? We can take the last element because we know that it has either the highest frequency or the highest key. In this case, we have a triple tie, but this one has the higher key, so we need to move this. Okay, so we move this here. And now we need to add 1 times 4 to current, so this is 10. Meaning the result of this subproblem is 10. And here we have 6 elements, and k is 6. So at this point, we can add 10 to the result. Finally, we are here. This is the current window. Here we have 7 elements. So first we are adding this, then we are subtracting this. Okay, so let's add this. First we go to the frequency map. We are checking if we have number 3. We have it right here. So somewhere we have a tuple with 1, 3. And that tuple is here. So we remove this. And now we are ready to add this. So we go to the frequency map again, add 3 and add 1. This is 2. And we need to add this information. So we go to low and add a tuple with 2 and 3. And now we're checking if we need to balance this. And here we have 2 elements. X is 2, so we can't add anything. But maybe we can swap elements. Maybe we can swap this 2 or this 2 or this 2 or this 2. And for this, we can check what's the frequency for the last element in low and the frequency for the first element in top. And this is greater than this. So we can swap these 2 tuples. We are adding 1 for here and removing that from here. So we are subtracting from current 1 times 4, this is 6. and we are removing this from low and adding a tuple with 2 and 3 and adding 2 times 3 to the result. So we add 6. This is 12. And what this means is the result of this problem is 12. Now the problem here is that we have 7 elements, but k is 6, so we need to remove this now. So we need to remove this. First we go to the frequency map and we have number 1 here, so somewhere we have this tuple. And this tuple is here, so we remove this. Now we are ready to add this. We go to the frequency map again, add 1, and we add a -1 here because we are removing this. So this is 0, and given that this is 0, we don't add anything to low, and we are checking if we need to balance this, and we don't, because here we have 2 elements, x is 2, and the frequency of the last element here is smaller than the frequency of the first element in top. So we keep this as it is, meaning the result of this window is 12. And here we have 6 elements, which is equal to k, which is what we want. So at this point we can add 12 to the result. So finally we return this. Here the complexity will be big O of n because we need to iterate this, log n, because this is the required time for operations in short lists. And space complexity will be big O of n. So with this in mind, let's go with the code. First we say n is the length of nums. The result is an empty array. We have a frequency map, which is a default dictionary with a default value of 0 for every key. Top is a sorted list. Low is another sorted list. And current is initially 0. We will have a function for every operation. We'll call this change. And this takes some number and some count. This count can be 1 or -1. We are building a function because in both cases we are doing exactly the same. Here we have a non-local char. This is how we can access this variable from within this function. Here we need to follow a few steps. First we need to remove previous state if present. Remember the approach. Then we need to add to low the corresponding information, and then we need to rebalance only if top is not full or we have elements to swap with low. Okay, so let's start here. We are looking for a key, which is frequency map at num and num, and we will call this previous. And with this we can say if frequency map num, if previous in low dot discard previous, else top dot discard previous and current minus equal frequency map at num times num. Okay, so if previous is not in low, it's in top, and we need to discard this, and if it's in top we remove the corresponding number from current. And after doing this we can say frequency map at num plus equal count. Now we need to add the corresponding information to low, so we can say if frequency map at num low dot add a tuple with the frequency of num and num. And now we need to rebalance if necessary. And for the first case, when top is not full, we can add the last tuple in low, okay? Remember the approach. So we can say while low and the length of top is more than x, frequency and key is low dot pop, the last element, meaning -1, and current plus equal frequency times key, and top dot add a tuple with frequency and key. Now we have another scenario, which is top is full, but the frequency of the last element in low is greater than the frequency of the first element in top. So while we have low, we have something in low, and low at -1 is greater than top at 0, frequency and key is low dot pop -1, and x frequency x key is top pop 0. Okay, we need to update current. This first we need to subtract x frequency times x key, and then we need to add frequency times key. Okay, and now we can add to low a tuple with x frequency x key, and we add to top a tuple with frequency and key. And now with this function we can say for I in range n, first we call change with nums_i and 1. In this case, remember we are adding the current element. And next, if I is greater or equal to k, meaning we have exceeded the corresponding window, we need to remove the leftmost element. So we call change with nums I minus k and -1, okay? And just to be clear, this is remove leftmost element. And if I is greater or equal to k -1, meaning if we have a valid window, we can add to the result current. And finally we return result. So this is the entire code. Let's submit this and see if it works. Here I put a semicolon, so let's fix this and try again. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, because these videos are very hard to make, and see you in the next one. Bye bye.